Yeah, I hope my screen is visible and audible as well.
Yes, sir.
Yeah, okay, fine. So last time we started with this, okay, building energy analysis tool. In fact, we were about to discuss passive strategies, right? And in the process, I said in order to understand passive strategies, we need to first understand how strategy works, okay, and there are two components that we need to understand. One is the building component, that is modeling component, and the other component is how do we define environment. Okay, this is what we were discussing last time. How this interaction takes place, how do we do this abstraction of building models, how do we do abstractions of environment, okay, and what is the common tool that we have for these two things, and then how do we take it from here. So in the process, we were trying to understand. Uh, I said there are a lot of tools are available for that, okay, and how this how in fact how these tools are classified and how it can be taken out. All I had discussed, and for example, let's say there are certain tools which are free access. Okay, energy simulation tools are some of the tools are freely available, and some tools require very minimal input. Okay, so I think one of the thing that you should understand is last time also I must have discussed building energy modeling can be in two ways. Okay, and probably I'll also highlight it today as well. One, we can go to the detailed level of analysis or building modeling, or it can be an abstract model as well. Okay, so so depending on the understanding that we have, depending on the availability of tools, this can vary. Okay, I'll show you some examples as well. And of course, simulations can take time, okay, or it can be for benchmarking and so on and so forth. All that is possible. Okay, then I said once we have identified tools for building energy modeling, okay, so there are two components to be done. Okay, one is of course modeling of the building, and the second component is defining environment. Okay, and this is what we discussed last time in great detail. Like when we do an abstraction of environment, we use weather data. Okay, we primarily depend on weather data to define the environment, and then later this abstraction of environment is given as an input for analyzing the buildings, for analyzing the building energy simulations, or running the building energy simulations, so on and so forth. Okay, so we had discussed how do we extract the TMA files, okay, and what is the difference between climate and weather file, and also I showed you some examples of where do we get the weather files and what are the issues with the weather file also we should keep in mind. Okay, so for example, let us say when we do an abstraction of building, okay, let's say it is, let's say, closer to reality, probably 99% of what is there, what is to be constructed, or what is there in existence in terms of buildings can be recreated in a virtual environment. Okay, so for example, let's say you do a case study of a building and we'll be able to replicate as such, okay, closer to reality. However, this is again, it is an abstraction. Okay, it's not 100% a real object, it is closer to reality only. Okay, so that means there is an element of error up to 5% or depending on the model, that what we get in the simulation versus what we get in the real time. Okay, there will be of course difference. Second thing is, this is in fact we have very sophisticated tools and we have made great advances in this aspect, where we can replicate the buildings in a virtual environment to almost accurately. Okay, that's one thing. On the other hand, we have to give an input that is on abstraction of environment. Okay, extraction of environment. So how do you define this environment, and how do we give that as an input for building simulation is a great challenge, and that's where we have this weather file. And I said that this abstraction is again, I think here it is, we are almost certain that it is as realistic as possible, but this is not even let's say 90% accurate also. Okay, because there is always difference between the abstracted environment, because we cannot replicate environment as such. Okay, it is just a model, and that model will have an errors. Okay, because it is difficult to model in natural conditions. But anyway, that is taken into that is well accepted within the research domain. So we use abstract climate models for running the simulations. That's one thing that we should always keep in mind, that whatever we do simulate is not going to be 100% realistic. Okay, that much we should keep that in mind. Okay, and I said there are different ways of getting the weather file. Okay, and also we went on to see a different how do we read the climate weather files. Okay, what are the different components of climate that is inbuilt in the weather file and what it can do. And in fact we did discuss about sun path and 3D sun path and so on and so forth. Okay, so before we actually head on to other things like passive strategies, and also there is a mention of building energy models and building energy simulation tools. I was just checking your syllabus. You can see here in the second unit, I think Karthik sir is taking this part, and there is also mention of softwares used for energy model, so which is very well within what I'm discussing. It's not out of context. And after this, probably once we said these things, we will go specifically and see what are passive design strategies and how it works. Okay, so I don't know whether if we should be able to complete today. Let's see how it goes. Okay, so what I'll do now is you can also download the you can also check these design consultants. Okay, climate consultant as well for your and see how climate data can be read. Okay, in addition to that, I'll show you this Andrew Marsh tool. We'll first explore psychometric chart, and then we'll come back to the other two. Okay, so let's go here. Climate component. We have psychometric chart. Okay, I think last time also I told you the end product Okay, so the end product of psychometric chart. I think this is this is discussed in your climatology subject as well. Okay, you must have definitely went through what is psychometric chart and how do we read this chart. Okay, what is the end product? What is the outcome that we can generate from psychometric chart? Okay, one is of course identification of which are zone which does not require any artificial or passive means of cooling and heating. Okay, this is one. Also, it gives an idea on which kind of passive strategies can be adapted to improve this comfort zone. Okay, that is the ultimate idea, that is the ultimate output that we can extract from the psychometric chart. Okay, I'll tell you how do we arrive at this comfort zone and what are these boundary lines, how is it drawn, what is this all about. We will discuss this today, but just keep that in mind that psychometric chart will be useful, is used for coming out with identification of comfort zones and also identification of suitable passive strategies to increase this comfort zone. For example, now this is the comfort zone, okay, as per the weather file. Okay, and this is where we theoretically we say that we don't need any artificial or any passive means for making ourselves comfortable. So which means, for example, let's say even we don't have to run fan to be comfortable. It's like that. In a very crude manner, if we can say, we don't need any support here, be it natural or artificial. It will be comfortable. However, if we just have to increase natural ventilation, let's say this comfort zone can be increased to this extent. Okay, how do we do that? How do we increase natural ventilation is what we are interested in. Okay, passive strategies. So how do you bring in certain passive strategies so that natural ventilation can be enhanced? Thereby we are increasing the comfort zone to a larger extent. Okay, that's the intention. That's the whole idea of this psychometric chart. Okay, so that's the just keep that in mind when we proceed further. Okay, so I think there was some, yeah. So if you check the psychometric chart, okay, there are different things. I'll just show you. For example, let's say it's normally drawn like this. There are different ways in which this can be drawn as well. It can be drawn in a rectangular fashion as well, but normally this is how it is drawn. What are the different parameters that is there in the psychometric chart? I think all this you must have read in your climatology subject, but again there will be something called dry bulb temperature, which is shown as a vertical line that you see here. Then we have something called absolute humidity, which is shown as a horizontal line. Okay, you can see, in fact you can see the units as well. Okay, vertical lines, the unit is dry bulb temperature, it is Celsius. We have the second component, which is absolute humidity. Okay, you can see the unit as well, which is plotted horizontally. Third component is humidity, okay, which is kind of a curve, parabolic lines, okay, which indicates percentage of humidity. So it is 100%, 90, 80, 70, so on and so forth. Okay, this is humidity, relative humidity, which is measured in terms of percentage. Wet bulb temperature, okay, and vapor pressure and specific volume of air, all that, and enthalpy. Okay, so let me turn on only few things, which is dry bulb temperature, wet bulb temperature, dry bulb, relative humidity, and wet bulb temperature, or I'll just keep this off as well. You can turn on, you can check all this for yourself, okay, how it works. Okay, so you can see all the values here as well, okay, depending on if you move a particular, this is point source information, so if you keep the cursor somewhere, it says what is the dry bulb temperature, what is the relative humidity, and so on and so forth. But we have not imported any weather file here as of now, so it is I don't know what is the default weather file it is taking, but it is showing some number. Okay, so let's import the weather file, load weather file. Yeah, I think this is what we downloaded last time, EPW file for Vijayawada. Okay, so now we have something very specific, which says for Vijayawada, where is it written? Yeah. So if you see here, we have certain information that is getting plotted. Okay, so we will just keep only relative humidity and dry bulb temperature. Okay, weather station information, if you just go down, it says which weather file and what is the latitude and longitude, and so on and so forth. Okay, so you can see a few more things which we have not imported the psychometric chart model as of now. It is just plotting of the what do you say, weather file, okay, into the psychometric chart. So it says there's some reading is also available here. It says 1 hour to 274 hours. Okay, so each cell higher the number, it says okay, you have we are having, let's say if I keep this point here, for more than 274 hours we have a dry bulb temperature of around 28 degrees Celsius, relative humidity of 88%, and so on and so forth. All that can be seen here. Okay, so and let's say these are extreme anomalies. We also call these anomalies. And what are anomalies? For example, let us say we have let us say we go here. I'll just quickly show something. Let's say we are plotting, let's say, test scores. Okay, and what is the average test score for, let's say, energy efficient buildings. Let's say we have done mid-semester assessment, and we wanted to know how the entire 80 students are performing. So what will be the case? Let's say we start from 0 to 100. Okay, and let's say there's a curve. I'll just put 50 here, and probably many are somewhere here. Okay, it may be something like this. Okay, so many are here, 50s, 70s, and 80s, and some will be here, and one or two may be exceptional, one or two may be this exceptionally positive, exceptionally negative as well. So which means these are actually anomalies. We are okay. We in statistical terminology, we actually exclude them from the group. We are interested in this for analysis. Okay, not as an academic assessment. Okay, we want people here primarily, but just from statistics perspective, we actually don't. We call this as anomalies, and in fact, this can be addressed in two ways. We give too much of attention if we find some information like this. We believe that this is terribly wrong in the data collection or assessment, so on and so forth, it can be here, it can be here as well. Okay, we get it out that whether these numbers are correct, whether we have done the assessment correctly or not, right? So that kind of issues can also be seen in the weather file as well, because you see, if I keep a we have the weather file plotted in the psychometric chart, and I have kept my cursor here. It says we have a dry bulb temperature of 43 degrees Celsius. Okay, so these are too too much anomaly. Okay, so what do you mean by that? You can see here it is 1 hour, probably 1 hour somewhere in the weather file. We get temperature as high as 45 degrees Celsius, and the relative humidity goes down as low as 20%. Okay, so which means very dry. Okay, so this will happen and this happens. Okay, this is based on the average data, so which means it is very much likely that we will have anomalies like this. But do we design something for based on this? We don't design something based on this. Okay, this is also one point that you should always keep in mind. Let us say we plot temperature profile, something like this. Okay, and we have extreme temperature. Okay, let's say this is normal temperature curve. Okay, from Jan to December, and let's say there's an peak. Okay, extreme temperature. There can be, let's say average is somewhere 35, but extreme can be like I showed in the diagram, it can be 43 degrees Celsius also. Okay, but do we design for 43 degrees Celsius, or we we design for 35 degrees Celsius? This is where we make a lot of errors, especially when we do building energy designs. We don't design for 43 degree extreme 1 hour conditions in the weather file. Okay, that's okay. We can't design a system that can tackle for 43 degrees Celsius. We are actually looking for this average extreme, average higher temperatures, which is 35 degree Celsius. Okay, so we design buildings for this. We don't design building for 43 degrees Celsius. It happens for, let's say, 1 hour, or let's say if you put all the data together, let's say it happens for some 10 hours in the entire 8760 hours. Okay, so we don't make our design for 10 hours. Okay, we agree that for these 10 hours it will be highly uncomfortable to live there, but it is just 10 hours, so we don't have to buy, or we don't have to make our designs extremely inclined for these numbers. Okay, so we take an average here and then we design for this. This is one thing. Second thing is, also when we do an let's say let's say this is an average monthly weather data, and this is peak temperatures. Okay, sorry, this is average temperature, monthly weather temperature. Let's say this is peak weather temperature, which means what is peak? Every day there is high and there is low, right? In actually, okay, I have deleted. Let's say if I draw one candle. Okay, so let's say this is today, this is 3rd March 2022, and let's say this is 0 to 24 hours. Okay, and we had temperature of I'm not check the numbers. Let us put some number here. Let's say it is 20, and again 24 hours, it is again 20. Okay, so in between we have a temperature range which is in, let's say, 24 to 30 degrees Celsius. Okay, but we have okay, let's say this is from the lower side and this is from the upper side. Let's say this is 40. Maybe we may have reached 40 degrees Celsius maybe for 1 hour. Okay, but most of the time the temperature was between 24 and 30 degrees Celsius only. We may have reached a lower temperature of with 20. Okay, but it is maybe for 1 hour. We don't design for 20 degrees Celsius. At the same time, we don't design for 40 degrees Celsius. Yeah, that's what I'm trying to say. We take the larger part, average part, where we design buildings for. Okay, both for natural ventilation and also for the artificial, not artificial, active strategies as well. What do you mean by active strategies? For example, let's say you are installing an AC. We don't install AC to bring down the temperature from 43 degrees Celsius to 27 degrees Celsius. That's criminal waste of energy, right? So ideally, what we say is we don't design our systems for this. We actually design our systems for an average, which is 35 degree, let's say 30 to 35 degree Celsius only. Okay, so this applies for both passive strategies and also for active strategies as well. Okay, so let's quickly get into other things. Okay, so once we have done this, what is this all about? What are the models? If you just click here, it says comfort model. There are different comfort models inbuilt in this tool itself. It says one is Gioni's Bioclimatic Model. I think this you must have read it. Okay, in your climatology subject, this must have been discussed. If not in detail, at least this the name Gioni's Bioclimatic chart must have been used. Okay, this is one thing. We have other bioclimatic models as well. ASHRAE 55 model is also there, and European model is also there. So the most commonly used model is Gioni's Bioclimatic chart. So I'll just click on this. Then it says it generates some information which can be will come to this. If you see here, there is only one parameter that we can modify here, okay, which is mean outdoor temperature. Okay, so sorry, I said when we superimpose the bioclimatic chart on this, when we apply a model, okay, comfort model in a psychometric chart or bioclimatic chart like this, we are getting some results like this. Okay, so which means we have developed certain models, okay, that defines comfort conditions. Okay, so these are actually called bioclimatic models. Okay, what is it? For example, let's say Gioni's bioclimatic model is one common comfort model that we have in hand. Then we have ASHRAE standards, and then we have European Unions developed specifically for European Union, and we also have one model for outdoor conditions as well. What are these models? These are actually models developed based on studies, based on a number of studies conducted over a period of time, and then abstracted, okay, taken, generated as a abstraction of understanding on comfort. Okay, so for example, in Gioni's bioclimatic model, okay, the entire model is dependent on outdoor dry bulb temperature. Okay, so for a given dry bulb temperature, given outdoor dry bulb temperature, what is the comfort condition for the entire time period? Okay, so in other bioclimatic chart, we have other parameters. I'll show you what are the other parameters that is considered for arriving at comfort zones and so on and so forth. Okay, normally we say that temperature, humidity, and air velocity have an impact on how do we perceive comfort. Okay, so but in bioclimatics model, Gioni's bioclimatic model, only outdoor outdoor dry bulb temperature alone is taken into consideration. Okay, so let's see this here. So let us say we are in Vijayawada and we know what is mean outdoor temperature. Let's keep it to 28 is also fine, I guess. Let's say 25. Annual mean temperature, let's say 25. I'll put it here, 25. Okay, so if we apply this particular model, bioclimatic model developed by Gioni, okay, so it says, okay, in the entire for the entire climate data that we have, okay, that you see here, okay, so maybe I can take this, we can plot this. I'll just do that. It will be useful for discussion. Okay, so this is number of hours, okay, and plotted in the psychometric chart for Vijayawada case. Okay, and if we superimpose the Gioni's bioclimatic chart on top of the psychometric diagram, it says we are comfortable here somewhere, okay, for this period of time. Okay, we don't need for so many hours, for so many number of hours, we don't need any support for making ourselves comfortable. Okay, but if you let us say if we have to if you have to calculate, we can in fact do these calculations as well. Actually, in the in master's level, what we do is we ask questions like heating degree days, okay, cooling degree days, how many heating degree days are required. Of course, for Vijayawada there's no zero. Let's say how many cooling degree days are there. Okay, how much we can arrive. All that we extract from here. Okay, probably will not go into that level. Just let us see the diagram, and then we'll see what kind of inferences that we can draw. Okay, so if you just look at this, and from this what we can understand is we are able to, will be comfortable in this zone. Okay, but if you just add little bit of natural ventilation into the building, the comfort zone can be extended till here. Okay, all this area, all this zone within this can be extended. Okay, or maybe not the entire one. Let's say only this part. Okay, only this part that you see here. This the days that falls within this region can be managed only by improving the natural ventilations in the building. Okay, so we'll be more comfortable, we'll be able to achieve comfort condition, okay, if we increase natural ventilation in the buildings. Okay, that's one observation that we can extract here. There are other strategies mentioned here. For example, let's say mass cooling in the sense, let's say if we have appropriate use of building materials, okay, so that will help in that will help in cooling of the buildings. okay, or let us say we have some evaporative strategies, or does it have any impact on the in the climate of Vijayawada? You can see it's hardly have any impact. So which means, let's say if we have a water body to be incorporated as a strategy in a climate like Vijayawada, probably we will get some results, but not that as good results as we can expect. Okay, for example, let us say this is the line for evaporative cooling. Okay, and you can see maybe there is some impact, but not as significant impact as possible. Okay, what is the major thing that we can observe is we need lot of ventilation. That much you can directly observe from this chart. Okay, so you can see the number of hours which is marked as dark. So we're just increasing by just improving the natural ventilation, we'll be able to achieve a lot of comfort in the in this particular climate. Okay, air conditioning and dehumidification is required in the region which is beyond this time zone, beyond this natural ventilation zone. Okay, so in fact we can take out a specific number of hours where we need cooling as a strategy. All that can be discussed using this strategy as well. Okay, and there are other things. For example, let's say night cooling or night ventilation. Okay, even this also have some impact on the overall overall comfort condition. Okay, we will be discussing about little bit on night cooling and night ventilations also. Okay, and mass cooling is I was just trying to say something. And evaporative cooling, yes, there is some impact on overall output as well. For winters, okay, probably there's no winter. It's hardly we have some winters. We can count the number of hours, okay, which is considered as winter as per this model. Okay, do we need passive solar heating? There's no, because there is no need, because none of the temperature or data set falls in this area. Okay, so there's no heating required, there is no active solar strategy required, there is no passive heating required. Okay, internal gains, there are certain slight issues. Okay, but I think these are all can be well managed in the design itself. Okay, so as far as this is, we are discussing only with respect to Vijayawada case. Okay, this is Gannavaram's weather file. Okay, so we'll probably what we'll do is we'll in the next slide I'll see if I can do that very quickly. This will be useful for myself and for all. Let's see, we take some other data. Okay, London. Okay, let's take London. It's already there in the inbuilt. Okay, I'll just plot this. Yeah, here again I have not changed the mean outdoor temperature. I am just keeping it as it is, but this may not be a true case in case of London, but for our discussion I'll just keep it as it is. Okay, I think this is not required. I'll just keep it like this. Okay, you can see this now. This is Vijayawada and this is weather file of London, and you can see where the number of hours, okay, how many hours, if you plot that, okay, if you plot the temperature, humidity, and all the weather variables, climate variables, this is where the profile can be plotted in the weather in the psychometric chart. Here you can see there is heating requirement, there is active solar requirement, which means bringing sun. Okay, bringing sun is one of the primary component of this zone. Okay, so we also have, this is passive solar heating. Yeah, passive solar heating, active solar heating, and this is heating. That is, for example, let's say you have what is it, heaters, heaters in the room, in the buildings. So there's a lot of heating is required in this particular climate. Okay, whereas natural ventilation is probably, okay, very less, because they will be more they will not be comfortable, okay, if we increase more ventilation. Okay, because it is already cold, we can't bring in more air, okay, outside air directly into the environment, because it will add to discomfort only for partly we can bring that. However, in our case it is exactly opposite. Okay, right, we need lot of ventilation, lot of ideas to bring in air. Okay, that's why last time also I was emphasizing this. Now also I'm again saying this. Please never take examples from these kind of climatic zone. Okay, please don't take case studies from London and say that I'm going to adapt that in Vijayawada or in Rajasthan or any climate. Okay, always please refer the climate zone. Okay, if it is closer to it, then fine, you can actually adapt it. Let's say what is closer, maybe let's say, can we take Singapore as our case area for study? Let's say superimpose Singapore. Let's export this. In fact, this is more appropriate for us than looking for case studies in Europe. Okay, so this is probably all the strategies that is done in this area. This is Singapore data. We can definitely use strategies that is practiced in Singapore for our climate. Why? Because you can see for them as well. If we improve the natural ventilation, okay, they will be able to achieve. In fact, I think they don't need any as per this particular data set. You can see I think almost 100% they will be able to achieve, not 100%, let's say 80 or 85% comfort conditions can be achieved only through natural ventilation as well. Okay, by default there's nothing like this. Okay, for us at least we are comfortable without anything. Okay, for them I think it's primarily natural ventilation is required throughout the year. So we can in fact look at case studies here and take some design guidelines for Vijayawada or similar climate, but we can't take this as a case study. Okay, this is one more thing that we should keep in mind. Okay, fine, let's see what else we have here. So if we, let us say, if we increase our outdoor mean temperature, there's a difference in, let's keep Vijayawada only. So if outdoor temperature is it depends on mean outdoor temperature. Okay, so if we keep high or low, you can see how the model is changing. Okay, so this is one model. There are other models, like for example, let us say one of the commonly used model is ASHRAE 55. If I superimpose ASHRAE 55, it says this is a comfort zone, and here we have certain more variables that can be that can be checked and that can be studied. For example, let us say one second, I'll just see. Okay, I'll just, yeah. For example, let's say if we increase air velocity, okay, can we increase the comfort zone? It is based on it is primarily based on adaptive thermal comfort. Okay, so for example, let us say if we increase air velocity or if we appropriately dress, okay, how the comfort conditions will vary. If you are doing nothing and if you are doing a lot of work, okay, metabolic rate have an impact on how do we define comfort. All that is can be studied. I'm not going into deep details. It's not relevant for you at the moment. So we are actually interested in here, where we can look for certain strategies, okay, so that we can take it into design considerations as well. There are other models as well. You can just overlap and see for yourself what kind of information can be extracted. But at least you should definitely check this Gioni's bioclimatic chart model, so that you can understand this diagram. Also, let me do the same analysis, same results in the climate consultant. I showed you there are two ways of doing it, right? So one is the Andrew Marsh tool, which is web based. You can also download this climate consultant, which is free actually, and run the simulations as well. Okay, let me download the okay, same information. I think we have seen this in the Andrew Marsh tool, but in the form of numbers that is shown here. Okay, and the models that I was discussing, okay, you can see the models that that is listed here. I'll just keep for the moment ASHRAE 55. We'll not go into details of this, but I'll just skip all this. These are variables that we can read, explore, or that is there in the weather file that can be read and we can extract from it. Sky cover, luminance, wind, velocity, and all that we can do. We are interested in something else. I'll just show you that. Okay, we are interested in this particular map. It also generates psychometric chart. This is based on the ASHRAE 55. This is old model, 2014. Here you can see this is 2017 model. ASHRAE 55 2017 model, but we don't. This is slightly old model. So here again we have different zones, okay, which says how much hour is comfortable, okay, how much sun shading of window is required for how many hours, 32% of the time in the entire year we need sunshades. Okay, high thermal mass can work in up to 5%. Okay, what is high thermal mass? All that probably there is one unit in your syllabus also. Here in the third unit we will be discussing that as well. Otherwise also these words are quite common now. If you are not comfortable, we will be anyway discussing in coming classes. I was showing something. Yeah. So we have high thermal mass, night flushing, evaporative cooling. These are strategies. Okay, we will be going through some of the strategies that is listed here as well. And this gives an idea that which kind of strategies will work here. Okay, which kind of strategies can be adapted to improve this comfort zone. That is the whole idea. You can do that as well and then check what can be done. In addition to that, it also gives certain design directions. Like for example, let us say in climate, there are both active strategy ideas are given, both passive ideas are also. It is an indicative. It gives an indication that how do we address the issue of discomfort, okay, through active and passive means, which we can take and then explore as well. Okay, this is not it's not idealistic, but since it is a beginning for all of us, we can in fact generate these results and check how this kind of ideas can be incorporated, and let's say how much of benefit it can generate if you do these passive strategies. Okay, if not active strategies, we can take only we can take only passive strategies, if not active strategies, to check how do we improve the comfort conditions. Okay, very simple explanations are given. Okay, so that is it about all that I have to say on psychometric chart. Okay, and how it is relevant for understanding passive strategies, specifically passive strategies, so that we have a fair understanding on that. Okay, so my recommendation or my suggestion is we should definitely explore this too. Okay, so the more, and like I was saying from the beginning, the more time we spend on data, okay, the better understanding we get. Okay, don't just Google it and then what is the easiest thing we do is, let's say if you do site analysis, we will say as the, let's say, a reviewer, we will ask you kindly show climate analysis of your site, kindly indicate wind direction, kindly indicate which strategies, passive strategies can be used. What we do, we just Google it and we say for a specific site, let's say Vijayawada, annual temperature graph, and just paste it on the poster saying, sir, this is annual temperature plot of Vijayawada, this is windrows diagram of Vijayawada, and this is psychometric chart for Vijayawada. Okay, so instead of doing that, okay, that has no merit. What you should do is you should generate these data set which is specific for you. Okay, design driven. Okay, what kind of strategies you can implement by using this data set is what is required actually. Okay, that can be done based on this understanding. Okay, so let's move further. So yeah, okay, there is a mention of building energy analysis. You can see here it says softwares used for energy models. So how do we arrive, or how do we identify softwares? In the first slide itself I showed you there are different building energy simulation tools are available, softwares are available which are open, data driven, benchmarking, all that. In addition to that, what I perceive and how I see these tools are when we do an analysis of buildings, okay, we look at how building works, right? For example, let us say if we very in an abstract way, if we divide the buildings, we can say that some part of the building is letting the sun in, Okay, some part of the building is directly in contact with earth, some part of the building is in contact with the external environment, not directly. There is a wall in between, and something happens within the room, and there is an element of shading in terms of roof and in terms of window shadings, right? So we have a phenomena where heat is let in through windows. So we have specific tools for analyzing only this. Let's say daylight. Okay, you want to analyze only daylight. So we have specific building energy, building simulation tools that can be used for daylight assessment. Okay, so which we can model the window size. Okay, in fact we can model the window itself. Okay, what is the kind of frame that we have, what is the kind of glass that we use, all that. Okay, so we can use tools specific to these kind of building physics interaction also. Okay, that's what I'm trying to bring, and we can do that same for other aspects as well. Okay, how heat is transferred from the building to the part of the building which is in direct contact with earth, or how the cooling component of earth can be brought into the buildings. Okay, or thermal mass, what is the kind of wall composition that we have, how this can help in reducing the heat coming in. Okay, or how we can make it light, let's say in cold climate, so that heat can come in. A lot of things can be analyzed specific to building physics. Okay, so in terms of opening, in terms of ground contact, in terms of external wall in contact, and also the conduction, convection and radiation. Okay, this I think again this you must have read in your climatology subject, where we say that how heat is dissipated is what happens within a closed room environment. Okay, so this is again we can use specific tools for this as well, and of course for shading and how much buffer or heat, how much shading can be used, how shading controls can be used, all that can be separately. Specific tools can be used for analyzing the building as well. Okay, so what is the summary? The summary is we can analyze building in two ways. One, whole building energy assessment itself. Okay, entire component of building can be analyzed, and there are specific tools for that as well. I showed you in the beginning of these slides. We have a directory of tools, building energy simulation tools. We can look for a whole building simulation, and there are n number of tools are available, which are open source, which are commercial, and so on and so forth as well. Or if you are just interested in looking for a specific analysis, for example, I'm just interested in knowing about daylight. Okay, we can use only one specific tool which gives output on daylight. I'm not interested in what is the energy balance, how much is the thermal mass, all that I'm not interested. I just want to know, if I put a glass, if I put a window like this, do I get enough daylight here or not? Okay, so we can identify tools which are specific like this, or we can use tools which are holistic in nature as well. Okay, all that is possible. Okay, so again, just to give an idea that I was discussing in detail about abstracting the environment. Okay, here I said weather file. Okay, we try to abstract the weather environment and convert them into weather files, and that is given as an input file, right? So it is an abstraction of environment. Okay, so actually there is a term called micro or meso scale climate model of XYZ city. Micro scale climate model of XYZ city. What does this mean? We have specific model for abstracting the environment. Okay, here I have just told you only about weather file. Slightly more things can be done, but that's okay. We will not go into that. So we are using primarily weather file as an defining environment. How about buildings? Building also can be abstracted. We can do building assessment, something like this. Okay, where we just give an volumetric assessment. Primarily we use this for solar exposure analysis or shading analysis, or let's say if you want to check the CFD, how is it impacting the building, we use this. Or if the scale of the analysis is big, let's say if you are doing urban design and you want to do all this solar shading, wind, all that, we can't do a detailed model for all the buildings. Let's say there are 1,000 buildings in your urban design layout. We can't be modeling this much, right? So we can use abstract models like this. In a technical term or in a research domain, we use this as, we call this as level of details. Okay, this is level of detail 1, which can also be used as a model, or it can be slightly improved version, LOD2, LOD3, LOD4, LOD5 is also there, 6 is also there, but it's fine. So what I mean to say is, we can do abstraction of the buildings as well. We have discussed about how do we do abstraction of environment. Okay, normally when you do an rendering of buildings, okay, which looks something like this. For energy models, energy assessment, we don't sometimes we don't need to do model as detailed as this. It can be as abstract as this, and it can be of course as detailed as this as well, but not every time. Okay, that's another point that we should keep in mind. Okay, I think I thought I can show you also on how do we do daylight analysis as well, very simply, but I think it's kind of beyond the scope of the subject. So, but you can explore. There are tools there, but if you require, you let me know. Sometime we can spend some half an hour time on how do we do daylight assessment very quickly without spending or without much complexity. Okay, there are many tools are available. Web-based tools are available for whole building simulation, and also for specific tools like this. One of the tools which we normally recommend is something called MIT Design Advisor. Okay, so it is an whole building simulation tool which is easy. The input data is very less limited, that can be used. I was telling you there are two ways of model. Okay, one is in a literature perspective, it's called white box model or the black box model. What do you mean by white box model is where here you know everything and anything about the models. For example, let us say here we have only we don't know how this zone is constructed, right? Let's say if I superimpose a Gione's biclimatic chart on this, I don't know how this zone is defined. What is the logic? What is the mathematical equation used for developing this comfort zone? How this zone is developed, natural ventilation zone. Okay, so I don't have a control on that as well, right? I can't modify that. So these are kind of a block. What do you say? Black box model. We don't know. We don't have control on the model, but we need only data inputs. Okay, so it can be abstract or it can be detailed one as well. So white box is where we have very detailed, comprehensive comprehensive modification possibilities. Okay, here in black box model that opportunity is not there. We can still do that in the model. This is one tool that we use, building energy simulation tool, which is called Design Builder. You can Design Advisor. You can check that in the in Google it and then see. In very let's say I think there are 7 or 8 input data that is required for running the simulation. Okay, where we can generate heating, cooling, lighting, comfort requirements can be generated in that. Autodesk format, I think many of you probably will be using Revit. Okay, so even whole building energy simulations can also be done in Revit. Okay, otherwise like specific analysis like solar exposure, like I was telling you. Okay, so specific assessment can also be done using for this particular tool. Okay, and there are specific energy modeling tools like VLEX for daylight analysis and energy 2D. I think last time I must have shown you. Otherwise also I'll be showing this when we discuss about specific passive strategies. Okay, for example, let's say Trombe wall, how it works. Okay, I'll show you how heat transport takes place between the wall, or what happens when we have that particular strategy in a building, so on and so forth. These are actually simple open source tools. Okay, there are very sophisticated commercial tools like Design Builder. This is not there, it's integrated with Revit now. Okay, we have eQuest, Energy Plus, or IES, Transys, Open Studio, Green Building Studio. There are so many energy simulation tools are there, which we can. This is a commercial tools are also there. Open source tools are also there. It depends on how we use, where we use, and so on and so forth. Okay, so this is at building level. Yeah. However, the similar analysis can be done at an urban level as well, but this is beyond the scope of our subject syllabus, so I'm not discussing anything on this. But just remember that whatever analysis that we do at the building level can also be done at a city scale. City scale, this is not at a city scale, sorry for using the word city scale. It's, let's say, neighborhood scale. Okay, let's say this is the profile of a street section. Okay, we can do all the analysis that we were discussing here can be done at an urban scale as well, neighborhood scale or urban scale. Okay, so one thing that I would like to highlight is we should have some scientific temperament when we do this kind of studies. Okay, that's why I spent a lot of time in explaining how do we understand this climate data. Okay, because everything is dependent on that, right? So when we say abstraction of the model, how do we do abstractions of the model? When we say abstraction of environment, how do we do abstraction of environment? And what are the components? Where do we how accurate all this? All that we need to know. Okay, so we need to have some kind of scientific temperament for this. Okay, that's one thing. Second thing is there are n number of tools available now. Now nobody can say that I can't analyze building for climate, or I can't analyze this specific thing, because plenty of information is available now. Okay, open source, all open source. I'm not talking about commercial platforms. All open source tools are available. Only problem is we should have this scientific temperament and the interest for exploring and knowing tools and bringing the results and so on and so forth. Okay, let us not just stick to the conventional conceptual development that we do. Okay, we should bring in some scientific analysis into the design development. Okay, so that is required. And one thing that I would like to bring it to your attention is, do we have to learn every tool, everything? Not necessary. Okay, not necessary. Even I don't know most of the tools that is listed here. Okay, probably I know little bit on eQuest. Okay, personally, I have used only eQuest, Design Builder very briefly. Okay, and Transys very briefly. Sorry, Transys very briefly, IES very briefly. Do we have to know everything? No, not necessary. Why? Because these are actually different kind of interface. Okay, interface for model, interface for assessment, but the inside model is same. Okay, many of the energy model is more or less same. Okay, so if we have good understanding on how a building works, what kind of input is required, the tools are just an indicators. Okay, so we can do that. And apart from that, we also have instruments as well for understanding all the subject. Okay, I'll also show you some experimental works that can be done for analyzing passive strategies. Okay, this can be done in the design studios as well. I'll show you some work on how it can be done. Okay, and of course we should read so that we are updated. Every day there is a new publication, new studies done on this subject. Okay, so for example, let's say this may be outdated list. Okay, so if we sit now and then look for current tools, there will be another 18, 19, 20 tools that has come. Okay, I don't know. I have prepared this some time back. So now additional tools may be there. Definitely will be there. Okay, that's how the field is emerging. Okay, so with that I'll just stop here. I have something put here. Maybe if you have understood this, you can do this exercise. Generate a 2D sun path for your house or apartment and see whether you are able to exactly plot your house and the sun path on your building on the sun path. Okay, and also let's see if you are able to at least take block model, or you can do a SketchUp model for your house, or maybe if you are doing your design work now, you can take that and then see whether you can bring in the 3D sun path and check whether whatever design interventions that you are giving is actually helping you or not. Okay. Third one, of course, you can check. You have to take the psychometric chart for your location. Maybe I think this you can try in your design studios. Okay, so you can take for your specific. I'm sure I don't know what is the design problem you are doing. I hope it is an individual work. So individually you should do all this work. Okay, please don't do anything in group, because individually you have to understand all this, master over all this. These are basic things. You don't need. It's not something which you can leave or forget. Okay, psychometric chart for a specific location. Just see whether you are able to do. This I have not told you, but so I am not expecting you to do that. Daylight analysis can also be done. This again, these two I have not told you, so you can just skip that. Yeah, these three you can try. Okay, so with that I'll stop for the day also. I have put some more things on, for example, let us say how do we design walls, passive design walls, how do we look at the entire building from passive strategy, how do we look at designing buildings for solar energy, how do we use thermal mass as a strategy, okay, how buoyancy effect or evaporative cooling effect can be used in buildings, okay, and how window design, skylights or lighting as a strategy can be used in the buildings. I will explain this and then we'll have a discussion on this. Okay, solar facades, night ventilation, wind. I'll show you because I have not discussed what is passive strategy, how it works. After discussing that, I'll also give you these references. You can check all this and then it will be useful for you. Okay, so I'll stop here and probably we can meet next week, and with next week I will try to complete this part. Okay, and